How many of you have done the homework? Installed the everything you need. Excellent. Cool, cool, cool. I'll give you a little bit about myself, just a background. I started in Java back in the day, back in the mid-90s, before it was actually even named Java. It was a cool project at Sun, and at that time I thought the cool thing about it is all the embedded possibilities. Well, as we know, Java never took off in embedded market as much, and I ended up writing a lot of kind of enterprise web apps in Java and so forth. So finally Android came about, and I thought this is something that's cool. I have kind of a personal interest, and I jumped on the bandwagon and started doing Android development, and have done a lot of Android training for large mobile companies, carriers, etc. So I don't have a lot of background in other mobile, like Symbian or BlackBerry or J2ME or any of that. I have a lot of background in Java and some in Android. So just to kind of give you a little background on all that. So Sasha asked me to start from the beginning. So assuming that you haven't seen how to start anything, so I'll just assume that you guys have installed Eclipse SDK, Android SDK. That's about it, right? So as you know, everything Android is at android.com if you need any references. So what we're going to do is I'm going to start my Eclipse first while that's starting up. And I'm kind of going to give you an idea of what I'm thinking of building in the short time that we have. And we'll see how far the project goes depending on your questions and how quickly you guys pick up and so forth. And feel free to interrupt at any time, ask questions, things like that. So it's supposed to be kind of interactive and all that. So obviously, almost everyone uses Eclipse to do Android development. So I'm launching. I just launched Eclipse here. I have a zillion-and-one project here, so we're not going to really worry about that too much. And hopefully Eclipse doesn't spin into rebuilding my entire workspace, which can take forever. So to launch a project, we need a emulator, right? Something that we're going to emulate the actual application on. And for that purpose, we use, as soon as this stops, we use this little Android Virtual Device Manager. This is something that's new since 1.5, right? Before we didn't really have multiple devices. We just had one. So this is what we use to create a emulator. So if you just installed Eclipse, you do not have any emulator. So you need to create one. I'll assume that I don't have any emulator. I'm just going to delete mine. So the way you create it, you give it a name, and you can be as creative as you want. I'll call my emulator. Okay. You must specify the target for this emulator. What the target is basically what do you assume is going to be available on the device that you're going to deploy your app on. Does it require latest greatest, or 1.5 is okay, 1.1 is okay, etc. You can also have some proprietary targets that are carrier specific or manufacturer specific, but we're not going to go into that. I'm just going to assume that I have vanilla 1.5. Next, what it asks you is the SD card. So what the SD card is the external storage. So basically, every device is assumed to have one and only one exactly external storage on which you can store your data. And there's different ways you can organize this, but the simplest one is to just specify the size, and you can put something like 10M, which stands for 10 megabytes. It's going to create a virtual SD card for your memory. Skins are your skins. A skin is also something that's new as of 1.5. Basically corresponds to the form factor of your device, right? So there are different. Up until now, we only had one form factor. We had the G1. That was it, right? But now, with the announcement of 20+ new phones coming to the market, there's going to be the ones with a square screen, with no keyboard, with stylus, with touch screen, etc., etc. So that's what this corresponds to. I'm just going to use the default skin, which is basically the G1 skin, which most of us are familiar with. You can click on. Typically, we would press enter here, but that does nothing. You actually have to click on create AVD. So there's a little bit of a non-intuitiveness in the in the Eclipse tool, but the price is right, so I can't really complain. Yeah.
Question.
I just personally haven't. So the question is about 1.6. I personally have not upgraded my installation to latest greatest. I'm still using one behind Eclipse and 1.6, etc. But there's no known problems with that I know. Yeah, I'll point that out once we create a project. So at this point, I have the emulator created. Its name is emulator. You can have as many emulators as you want. So you can be testing your app against different model phones, basically. So I have kind of a application that I built before, and I'm just gonna kind of run it before we start going toward that. So it's called Golf Caddy. And it's basically a little application that is used for you to keep track of your golf score. As you play around, you can record your strokes, right? And the idea behind this is I could have picked any application like a to-do list or Notepad, whatnot. It's not really that important what it is. It just illustrates a simple UI, some kind of data structures, how to handle events. And then we'll see how far we get if we're going to save it to the database or not, etc. There's a lot we can evolve this app to. So it's just a very basic, kind of like if we did a web application, I would talk about writing a blog, right? Everyone gets it. So this is kind of my equivalent for Android. It's asking me how I want to run it. I want to run it as an Android app. So if everything goes well, it's going to launch my emulator that I just created. And you can kind of see. And this is the part that takes a while to actually boot the device. The good thing is you do not have to restart your emulator as you change your code. A lot of people in class, I noticed, kill the emulator, restart it. It just takes a lot of time, so there's no real good reason for that. So this is booting. This is a brand new emulator, basically a virgin installation, never been used before, so presumably. And while that is actually booted, I'm just going to show you on a command line if you guys care. But all this stuff, there's a directory in your home directory called .android, and all this stuff is stored in there. So in your on a typical Unix, Linux, Mac OS, so it's going to be .android. It's actually on the Windows is also .android, but it's not a hidden directory. And if you go into AVD, which is the Android virtual device, cd.android cd-avd, you notice that there's a avd.emulator.avd, which is the actual emulator. It's what gets stamped onto the device. So it's all the underlying Unix file system, basically. It's the image that gets put on the actual device. And this is the just the INI file, which I'll just cat INI and tells you a little bit about the path of that device. And if you look at emulator.avd, you can see that there's a bunch of images that correspond to different mount points on your file system on the device. So hopefully, no, this hasn't started yet, so it's going to start soon. In terms of the tools, as I said, you basically just need the Eclipse, you need your command shell, and you need the emulator. That's about it. So this should be coming up shortly. Well, while we wait for that, why don't we do this? Why don't we start our project? So we're going to create a brand new project, never existed before. And to do that, basically click on File, New, and then Android Project. If you do not have Android Project here, and do not have it under Other Android Project, Android Project, then you didn't set up your Android SDK plugin for Eclipse properly. Right? So basically, there's different ways. It may or may not show under your File, New, but if it doesn't, then look for it under File, New, Other, and then look for Android, and then Android Project. Everyone got it? Cool. Click Next. And so this is the big screen that is somewhat important. So I'm going to walk you through what means what. So the project name is an Eclipse construct, so it can be anything that is allowed in Eclipse. I'll call this project golf score, something simple. Golf score is good. It's a brand new project. It's going to go into my Eclipse workspace. Now what it's asking you here for the build target, it's saying for this to successfully run, what kind of device does it require? Right? Can you guys see? Yeah. So basically, if I need some latest greatest 1.6 features with some proprietary third-party APIs, then I would specify this app is only designed for such and such device. Right? Remember when we created the device, we said what the device is capable of, and here we say what the app is requiring. So that those two things need to match, otherwise the app is not compatible with the device. So I'm going to say this is just a 1.5 app.
What is the Google APIs?
So Google API is really just Android 1.5 plus some proprietary Google stuff. So it's really 99% is the basic Android, but that plus stuff is specifically Google Maps. So in other words, if you're T-Mobile, for example, and you want to ship your device with some additional secret sauce that's only available to your customers, you would create a target that would be, T-Mobile APIs or something like that, and then you would create a custom package for that phone, and those phones would get stamped with that target, etc., etc. So, but for now, we're just going to use the vanilla. App name is going to be the application name, so it's basically the Android construct. I'm going to call it golf score. Package name is going to be your Java package name. So this is important in Android because the security is based on the Java package naming convention. So I'm going to use com, and I get a typo here, golf score, com golf, that's fine, com golf. It's asking me if I want to create an, yeah.
I'm sorry.
So the question is about 1.1. The way Google packages it, just to kind of open up that, hold on. The way Google packages the SDK, I don't know if you guys noticed, but basically, I think this is 1.5. Basically, everything gets packaged multiple times. So if you go on the platforms as of 1.5, you actually have 1.1 and then 1.5, etc. Just the common stuff gets put in tools and so on. So basically, 1.6 would probably have platforms 1.5. They maybe don't want to triple the size, so maybe that's why they yanked it out. But you can easily just take the stuff and dump it in. Yeah. And then the add-ons, just FYI, go into the add-ons and you create a whole image and stuff. If anybody cared. Google APIs is a good example for that. So back to this. We're almost done with this. Initial create activity. So this is asking me, for those of you, is anybody not familiar what activities are? Okay, cool. So activity, so there's some basic building blocks for Android apps. Okay. So activity is basically a screen. So it's something that is visual that you can see on the screen at one point in time. Okay, there's only one activity that is receiving user input at any point in time. One application can have multiple activities. Okay, so analogy I use is a website has multiple web pages, right? So similarly, an Android application has multiple activities. You would have a initial web page, like a home page on a website. Similarly, you have initial activity, like the home activity that you open it up. When your app starts, that's the first thing that comes up for the user. So I'm going to call it also golf score. Yeah, it's a UI thing. So activity is strictly, it's a UI, it's a visual something. It's basically something that takes one screen. So just to kind of switch back to my phone emulator, which has booted by now. So this would be one activity. This entire screen would be one activity that we have here. It's got different widgets or components on it, but that's one activity. I can have a separate activity. This is now a second activity for preferences, but it belongs to the same application. So kind of like a website with two pages. So, and I can use the back button to go back, just the way you would use it in a web browser. So those are activity is a construct in Android. The only other main construct that you need to know for now is intent, and intent is a way we start activities. Okay, so if I use the web page analogy, an intent would be a link, a hyperlink. Right, so you have pages and you jump between them using hyperlinks, kind of. So that's what. There are other constructs, but don't worry about it for now. So this is the simple app, sort of, that we can build, we can modify. It doesn't have to be the same way, but basically, as you play, you keep track of your strokes. You click OK. It gets added. Play second call. This one I did 4. Keep track. What this is a timestamp. I just didn't polish it enough, but that represents a timestamp there, so don't worry about it too much. But basically, I played 3 strokes here, 4 here. On the next call, I was in the sand trap. I got 6, etc. So that's sort of what this app looks like. Very basic. It's got some UI components that we're going to talk about, because you got to start with the UI, and that's, you get the most bang for the buck. You can see something, right? It makes you feel great. And then we're capturing some events and so forth. So that's sort of what we're going to work on. So let's going back here. So we're basically done with the screen. Minimum SDK level is really, I don't know why it's even put here, because it really corresponds to this. It's basically right here that this says minimum API level, and essentially whenever API changes, this level changes. So from 1.1 to 1.5, we changed the API level, so that's why we're now at 3, not 2. 1.6, if API changed, it would be something different. So it's basically saying it could be a minor upgrade, it could be So if it's if it's a substantial update to the SDK, because of the backwards compatibility, this number changes. And this is the number that basically matches what's on the device versus what the app is requiring. And if the app is requiring higher than what's on the device, it's not going to run. All right, so we're done with setting up this project. Boom, click here. And we are now back at essentially having the equivalent of HelloWorld. In other words, an app that does nothing other than just say hi, something like that. So if I launch it, you can see it's going to come here shortly. And here's our application. So this is the equivalent of HelloWorld, right? It just says Hello World, golf score. That's our app. That's it, right? There's nothing much going on there. If you go back to the home screen, you can see that this app is now available here. So you can just start it from the home screen as well, and so forth. Okay, so far so good. Okay, cool. So the first thing that we're going to do is we're gonna work on. Well, let me show you first of all just the lay of the land, what the project looks like for those of you who are kind of new to this. So basically, all your source code goes into source src your package, and then this is my source code golfscore.java. I'll open it up. Don't worry what's inside for now. We'll get back to it. This is the generated code. For the most part, you don't care about it. The only file that's there typically is r.java. I'll talk about this shortly. It's basically the glue between your resources and your Java code. Now, what are your resources? Resources are basically everything that's not code. So images, labels, screen, layout, things of that nature. Everything that's not code is basically a resource. So Android does a really good job of separating stuff that actually executes from stuff that is more of a UI/data/graphics type of stuff. In this example, we have our screen here. I'll double click on this. This is our main screen, main layout. And we'll get back to that one in a second. And then finally, the other file that kind of matters is Android manifest file. And I'll open it up. You may notice in the Eclipse tool that I opened up an XML file, but I got this kind of layout of the XML file. It's not quite clear why, right? It's basically the Eclipse tool for Android is smart enough to show you appropriate UI for editing an XML file. If you just want to look this XML file straight up, you can just click on this tab here, and this is basically the meta file that describes this app. So all the stuff that we put on the first screen, remember when we started the project, is here. So our package name, our initial activity, minimum SDK level, all sorts of things like that. Okay. So that makes sense to everyone? I'm good at that? Okay, cool. So there's really typically nothing for us to modify in this file at this point. The file that we kind of care about right now is this file here. And it basically corresponds to our screen. So let me make a little more space for this. And I'll explain what this is. So basically this is the layout file. It describes our screen. So in Android, there are two ways you can build your UI, your user interface, right? One way is to code it in Java, so you can program everything in Java. Is everyone familiar with like AWT, Swing, any of that? Okay, so you can do that approach to build a UI. You want a new button, you say my button equals new button. Yeah. Would Swing be to resource cabin? Well, this is not really using Swing or any of that. But the reason why I ask if you guys are familiar with Swing or AWT is because the approach is very, very similar. So the API and everything else, all the design patterns are very similar to Swing and AWT. So AWT and Swing, although conceptually they're very different in terms of how they run, their API is almost identical. So so Android uses the same approach. So that would be the programmatical approach to building UI, and I'll get back to that. So you guys will see how to do it programmatically. But what's cool about Android is that it also lets you do it from XML. So you can basically declaratively create UI. And that approach is more similar to building a web page. So everyone's familiar with Dreamweaver, right? You want a button or text something, you just drop it in. So I'll kind of like show you. So if I wanted like a button here, I can just take a button and poof, drop it in, and there's my button, right, on my screen. So I would have that button. Here's, and then you can edit certain properties on that button. So for example, if I wanted to change the text of that button, I would say this is my OK button. Boom, there's my OK button, right? So that's basically how you build that. Now, in terms of what's available on the how you lay this stuff out, it's using Layout Manager. So that's why, if you guys are familiar with Swing or AWT, it's the same idea of using a Layout Manager as something that is a container that decides how to stretch components within itself, right? So let's think about this so that we have actually something that we're gonna build first. So let's think about our UI. What do we wanna capture? So if I just wanna have a plus button, a minus button for my strokes. I wanna have the number of strokes that they have played, and then save and go to next kind of feature. Something very, very simple. And then I wanna have maybe a label, something that says here what the name of the application is. So let me start with this one. So right now it says HelloWorld golf score. Okay, where's this data coming from? So if you look at the properties, and although there's a zillion and one property, typically each widget has like 1 or 2 or 3 properties that really matter for it, right? And then, so that's, I'll kind of like fast forward to certain properties that are not that important. And before we jump into that, just in terms of the language, although these components in in Android are called widgets in terms of the UI, but there's also something called a widget that you may be familiar as a user, right? That you put on a home screen. Those two things have nothing to do with each other. So there's a widget that you as a consumer would put on a home screen of your Android device, and then there's a programmatical widget or view that we have. By the way, for those of you who come from Java experience, what's a component in Java would be a view in Android. So just to kind of give you an idea. So all these things are views, and these are the layouts. Layouts would be basically containers. Okay, so back to this one. So where is the data coming from? So if I scan through this, you would notice that text comes from something called text/hello. So let's double click on this to figure out where this is coming from. So basically, Android tries not to hard code labels and things like that, because you may want to support multiple languages, multiple screens, etc. You want to extract all that stuff into a separate file. So just for that purpose, there is a separate file, and it's under values. It's called strings. So basically, all the strings are extracted in a separate XML file called strings.xml. You'll notice that there's a similar logic for arrays, colors, all the other stuff that you may want to extract. So in strings, we have, you can view it like this, and there's our string hello that has a certain name and has a certain value, right? You can also view it like this as an XML file. So let's just do this. I'm gonna change this to title, okay, and I'm gonna change this to say golf score, something like that. Okay, so that's my app name, and that's the title. Or actually I even had the app name here. That's fine. One has space, the other one doesn't. I save this, and it automatically gets updated here. So basically, this is the reference to another resource. So when you say add string, you're referring to a string resource with the name hello. So it goes and pulls it up from there. Okay. Or in this case, it's not pulling it up. Oh yeah, that's right. So I changed the title. So we need to. You can type it here, or you can click on this little tool. So this is where Eclipse plugin comes handy, and it figures out what's available. So you can just click on this one. You can even define a new string here. Okay, and there's our golf score. Or you can be lazy and do it improperly, and I do that sometimes because just for the interest of time, although it's not the best practice. But I could just type it here and say golf score and call it a day. Oops, you actually don't need the quotes. So that's another option. So you can just do it like that. Okay. So let me basically just pick the title again. I'll do this one properly. So I may want to style this one up. I may want to make it slightly bigger. So to do that, there's a property called text size. You could do something like, say, 24 pixel, and that would make it 24 pixel big, right? Everyone understands that. But this is not the best approach. In terms of units on Android, there are basically a couple of new things. One is DIP, or DP, density independent pixel. Okay, and so basically that's a pixel that is independent of the density of the screen. In other words, it's gonna show properly regardless if it's a big app, then everything is gonna look bigger versus a small app on a, so if I had a screen that's much more dense, say I'm deploying this on some kind of home entertainment Android system that has much larger, like big screen size screen, right? Then this app, if I hard coded it using pixels, would only show in the small area of the screen. That's not exactly the behavior you want. So as opposed to using pixel, you're gonna want to use DP for units in Android. Now, there's also different unit for text, and for text there's something called SP, which is basically used just for text, and it scales with the user's preference for small, medium, large font right? So if a user wants large font, regardless of what type of screen the user is deploying on, then everything that's text would show up bigger. So the best practice would be to use SP basically here for text. But everything else that is a size-wise thing, you would use DP. So give you an example of a DP. I may want to put some padding around this element. And to do that, I can just basically do padding. I can say I want to do 20 DP padding, and there's my padding, right?
What units are DP?
So DP is equivalent to pixel on a 160 DPI screen. So on a screen that has a density of 160 pixels per inch, or it's 1-to-1. So as your screen density increases, so does the DP. Versus pixel, it doesn't. So now that I have that, I may also want to, for example, I may want to center this. So this is non-intuitive in terms of centering it, but basically, it's as opposed to alignment, it's gravity. So you can set gravity to something like center, and that would put it in the center. Okay. So far, so good on this one? Okay, so another thing that I wanted to point out is certain graphical elements. So this XML UI that we're building is going to get inflated into a Java memory space. So you are actually going to have all these objects available to you in Java. Now, for the most objects, you don't care. For some objects, you don't care to have a reference to. For others, you don't. You do, right? The way we're going to get the reference is by looking at the ID of that object. So let me see where my ID is. So this one doesn't have it, which is good because we don't really care about its ID. So we're not going to be looking it up. Okay, but for a button, I'm going to actually care about how to get to it. So I'm going to be changing the ID of this button. So this is going to be my OK button or save button, whatever you want to call it. So I'm going to change the ID of it from button 01, which is just the default one, to something like button OK. So the scope is going to be available within the context. The context is essentially your activity. So there's something called a context with a capital C, right? And it's basically activity in this case. And we'll once we get into Java code, we'll look how to look this up. So we're getting there. So let me just put a couple of elements and kind of do this, and then we're gonna go into that. So we have the OK button. I wanted to create two more buttons. One is for plus, minus, and I wanted to put a label, right, to know what my current score is. So I'm gonna put two more buttons. There's my button 1, button 2, and then I'm gonna have a label. A label is gonna be basically just to tell me what the current score is, and the label is called text view. So that's gonna be it. Now look how everything is just kind of lined up one below each other. So what do you think is controlling the layout of this? How this is laid out on the screen? Yeah, it's the layout manager that controls how elements are dropped. So as you can see here, I basically have the parent container, which in Android world we call some kind of layout. So in this case linear layout, and it's got these are all children of it. So you can kind of think of it as a DOM tree in HTML. So you kind of have the same structure. Or if we flip into XML, you can kind of see how that looks. And by the way, you can control Shift F to kind of fix the formatting so it looks a little better. But there's basically a linear layout, and it's got a bunch of children, which are all text and button, to keep it simple for now. Okay, so this is obviously not the way we want it to look, because we would prefer this to be kind of like in one line here, right? So what I can do is I can create another linear layout and basically put these elements on it and kind of sort it out in a horizontal fashion. So I'm just going to do that here. So I'm going to drag a linear layout at the top. And I didn't quite get it to the top, which is good actually. I want it right below the text here. And now I'm going to make these buttons children of linear layout. And to a certain extent, you can use this WYSIWYG tool. At some point, it breaks. So at some point, you're going to have to, it's not perfect. So at some point, you have to actually go deeper into the actual XML and modify it. Yeah, you can't drag and drop here. It doesn't work. And sometimes it gets stuck. And sometimes your XML actually gets out of whack and the actual WYSIWYG tool doesn't even support it. For certain components, it doesn't even work. I forget which ones, but there's, I think, a scroll view or something like that. It doesn't even work, so you have to kind of like do it, everything from Java, so you kind of don't really see what it looks like until you run it. Yeah, that's the problem with the Eclipse plugin. So and that's just a tool. So it's not, as I said, the price is right. Can't really complain. Tools are not perfect, but they're there. So somebody's going to make something better. But for now, it's pretty good.
It's not
No, it's not an Eclipse problem. It's just the plugin, yeah. So I'm just saving that. Okay, so I'm going to modify this really quickly. So I'm going to make this button 1 as opposed to saying button 1. And as I said, I'm going to do a quick and dirty here for text. I'll put minus. For this, I'm going to put plus. Okay. For text view, a text view is going to be basically my score. I'll call it strokes. Or score. Score's fine. And it's going to get overridden, so the actual value here is not that important right now. Okay. Because that's just going to be, that's just my placeholder right now. I'm going to have an OK button. So let me just kind of point something out. Notice how this is just taking as much space as it needs. It's not taking all the space. Okay. So, so in terms of layout managers, there are two things that are important, and they're width and height, right? So let me just kind of point this out. So in terms of width and height, they can have a value such as 200 pixels, which is not that interesting. Most often the value that you want to put is either wrap content or fill parent. Those are your two values that you're most commonly going to use. So for the height, if I did fill parent, which doesn't make sense, you can kind of see that this box is just expanding. And because this box is not the most visual, let me demonstrate that on something that is more visual. So, for example, I put fill parent on the OK, and you can see how the OK button just took all the vertical space that's available. So that's not what we want, right? We want to do fill parent. But for the actual layout containing these boxes, I probably want to stretch it across to take the maximum amount of space. So for that, I'm going to basically say for height, wrap content, so take as much space as you need, right? And for width, fill parent, in other words, be greedy. And then you can basically say how big you want specific items to be. So for example, I can say for the button, as opposed to saying layout width, I could put, for example, put height, something like weight. Weight is basically saying how much to scale. It's a number between 0 and 1, and saying how much to scale given the available space. So be greedy, but not overly greedy. Because if I didn't have this, if I just basically said go for width that is fill parent, then minus would fill parent and push all the other children or siblings outside, right? Which is not the desired behavior. So our desired behavior here would be to basically say take as much space as available. Similarly for this one, we're going to say the width, height something like this, probably here. And now we have something that looks reasonably well laid out. So you can kind of press the buttons. They're all about the same width. And so we did this in a very nice way as opposed to specifying 200 pixels, which we could have done, right? I could have done here as opposed to doing this. I could have done, go 200 dp, right? But this is not a good practice because you're hard coding it. It's gonna look, it's fixed, and on different screen resolutions and such, it's not going to display properly, so on. So it's much smarter to have it figure out how much space to take given some kind of set of rules. So that's.
The question on the weight, is it the higher the number, the higher the priority?
Yeah, the weight is actually just between value between 0 and 1.
Oh, okay.
Yeah. So basically, what I'm saying here, it's putting half. So these guys have much more priority in grabbing available space than this guy. So yeah. But for simplicity reasons, you're typically either nothing, which is defaults to 0, or 1. So. And you can do other things, like you can specify layout gravity, layout margin, and so forth. But this would be your typical type of layout stuff that you deal with. So it can get more complicated, but for the most part, this does the job. And I may want to make this score text size maybe slightly bigger. And remember, we use SP for something that's intelligently going to scale. And I'll put like 999 because 99 because this is just a placeholder for me to see what the number is going to look like for now, because it's going to get overwritten by the actual score. So I'll just put something like that. The question was about the width and height if they're dynamic. If you use field parent or wrap content, that's going to get dynamically calculated when the element is about to be placed in its container, i.e. layout manager. So as the screen shifts on different applications, and we can demonstrate that. You know what? Let me just run this app, and I'll demonstrate that right now. So I clicked on this little button, and you can see here what's happening is this app is getting, and actually let's read the console, which is not good right now because it says it's failed. Why is it failing? Once in a while, it loses connections. My emulator is just not responding right now, and I'm not quite sure why. It happens. So I'm gonna relaunch it, which actually goes through starting a new instance of an emulator, which is not ideal because it's going to take some time now to boot it up, exactly what we don't want. There's basically a mechanism, the ADT tool, which you guys, some of you know, which is basically the connection between your Eclipse and your emulator. All this stuff you can do from a command line as well. If I wanted to fire off my emulator, I can just type emulator, and then if I have multiple AVDs, I would say dash AVD and then the name of that emulator. So you can start it from a command line as well.
What about the SD card?
So that's a good question. What about the SD card? Now you can, there's two ways you can assign an SD card to an emulator. One way was when I created it. You saw how I did. I filled in the blank for SD card. Second way is to use a command line tool called mksd card and say how big of a card. So you can say 10M for 10 megabytes. And then you can say where you want to store it. So I may put it in /tmp/sdcard.img. And this actually creates a file on my file system, which is about 10 megabytes, and it's going to represent my SD card. So if you want to have an SD card with a bunch of stuff, like for example you have movies or music for your app and you want to share it among different emulators, this would be a good approach. And then you attach it to the emulator. And you can attach it to the emulator by starting it from a command line with, well, I guess never. So with dash SD card option. So I'm not going to do it, but you can do it that way. So you can attach it to. So you can basically have SD cardless emulators, maybe multiple ones, and then share SD cards among them. But that's useful if you have data that you want to share. for test purposes and such. But for simplicity purposes, I just started with a blank. So here's my app, right, that we built so far. So it's starting to look like complete that, like something that actually looks like it could do something. There's no Java logic so far. We just designed the screen. So let's simulate what happens if I resize the screen. Well, I can't really resize the screen because it's a fixed phone. But what I can do is I can flip the screen by pressing Control F11. Okay. So I basically, it's the equivalent of you popping up your keyboard on a G1, or on as of newer versions of 1.5, they're actually smart. So when you rotate, the sensor notifies to do something. Well, that doing something actually wipes out the entire UI space and recreates it. It's a very expensive operation, as a matter of fact. It's very, very expensive. Everything gets created from scratch, and one of the most expensive things you can do on the phone is to create the UI. Right? It's like ridiculous.
Why don't they map it and then save the state unrotated and then only paint the parts that are exposed?
You can do that. I've done that for a couple of apps where I said, forget that. Do not regenerate my screen. You have control over that programmatically. And I would say, okay, when there's orientation change, there's a listener that you can subscribe to, and you say, when there's a change in the orientation of the phone, this is the logic that I'm going to run through. And if I'm only changing the layout of one component or such, because you're not often changing everything, right? I may change just the position or something like that. Then I would do that programmatically. As opposed to redrawing the entire screen, I'm just changing something programmatically on one component. So you have a control over that. Yeah. The question is, how do you handle this? And I'll just mention it. That's a important topic, but there's so much to be said about UI optimization. So I'll just touch on top of it once we get to it. But you can see now that my screen, this line here, plus minus OK, it's stretching properly across, right? So it's dynamically refiguring out. None of this is fixed width, right? Right now, this OK button is much bigger than it is right now. And there's basically, sometimes there's a bug on the emulator when you go back, I noticed. I don't know why. Just on the way back, not the initial. So, but see how now it's smaller. So we dynamically refigured it out. So we have our basic UI here. Presumably we're going to have one more component here to drop in the scores so that we can keep track of scores. Let me just add that one final component, and then we're going to switch to Java. So that final component is basically, I'm going to just use another piece of text. So big text view, boom. And I'm going to drop it right here at the bottom. See, it's outside of my linear layout, so this linear layout, so it belongs to this linear layout. And another thing that I want to do is, you can see how it's small, but that's going to be where I'm recording my scores. So I'm just going to make sure that its width is fill parent, so that, just see how it stretches all the way. So that's so far what I'm going to do. Okay, we're basically done with the widgets that we have for now, but now we're about to switch back to Java. And before we do that, what we need to do is we need to figure out how we're going to identify, how we're going to pull different widgets from the XML, right? So what we're going to do is, for the ones that we care, we're going to assign them ID. Okay, it's kind of like, for those of you who played with DOM, you know how you can assign ID to your DOM, to your divs, spans, things like that in HTML, right? So similarly here, I have this button 1. Its ID is button 1. That's meaningless to me, so I'm gonna rename it to button minus. Okay, which is much more meaningful to me. I'm gonna rename this one to button plus. This was already renamed to, or was it? No, it wasn't. What was the ID for this? I'm gonna rename this one to score, and I usually name them what they are first. So this would be text score, but this is just my naming convention. I've seen people in terms of this XML stuff. I've seen people do different things. There's no clear convention, so some people use capitals, etc. I like to say what it is first and then followed by a short name using the Java camel case convention. And this is my button OK, which we already named. So you can now see the names are much more meaningful. And then at the same time, this one is going to need also a name because I'm going to be dynamically putting something there, and I'm going to call it text scorecard. Okay, but there's some that don't that have a name, and the name is not important. For example, linear layout. There's nothing that I'm dynamically going to do to it, so I'm going to actually strip its ID, just because otherwise it just flutter. There are cases where you may care about dynamically doing something to layout, such as if you're trying to make your UI more optimized. So maybe you're changing the layout orientation dynamically, programmatically. In that case, you would want to get a hang of it from Java. And by the way, this is just a nice thing that I realized from example to arena, as opposed to putting text view here. You may actually, since this is going to get overridden anyway, you may actually put some kind of text that is more meaningful to you. Maybe, score card info goes here.
So that text view is going to get multi-line or one line?
I'm going to do it just by putting a \n, new line, for now. Ideally, this would be a list widget. So I just kind of want to keep this example whole and complete through multiple iterations. So we're just going to do it quick and dirty, then we're going to yank that out, put a list view, etc., as opposed to going down the path of list view, which is actually complicated because of the adapter pattern, which I need to explain, and so forth. So if we get there, great. Otherwise, I'll keep it like this for now. Okay, so now just kind of to give you an overview of what we've done in terms of XML, I'm going to reformat this so that it's more legible. But you can kind of see that we have a linear layout. It's got a text view. It's got fail parent, trap content. All the stuff goes here. You can kind of see all these Android attributes like the width and the height. But for the most part, every widget is going to have height and width specified by default. Some you may have ID for, and some you may have additional stuff like text for, right? Depending on the type of widget. ID you specify, but you might have noticed that is @ plus and then ID and then / the name of it. Okay. So that's basically our XML, and as you saw, that automatically becomes our app in terms of the UI. So let's now before we jump into our Java code, which is this file here. Okay. So before, well, let's start with this, and then I'll jump into the other file that I mentioned, but we skipped through. So basically, this is our activity. This is all the Java code that gets executed, and we actually didn't write any, but our Eclipse template just put it in. And what this does is there's a life cycle that your activity goes through. So, how many of you are familiar with that life cycle? Just a couple of you. Okay, so let me just pull this up because I have something on this that I'm going to show you. Images and then life cycle. Let's look at this. So, unlike typical desktop applications, which you start, run, stop, your Android activity is basically being run through a certain lifecycle by the lifecycle manager. And you are essentially just providing the callbacks. So this is a typical, not just for activities, for services and other things like that. So for those of you who are familiar with writing applets or writing servlets or writing any of that, that's a pretty common pattern. So you basically provide hooks or callbacks or whatever you want to call them for your activity. So these are the states that your activity runs through. It gets started, okay? At some point, it's running. When your activity is running, it means that it's the one and only activity that is in user space It's the one that's receiving all the UI input. Okay, so only one activity has focus at one point in time. That's the one that's running. Okay, you could have multiple activities visible at the same time, but one of them would be behind the one that's in focus. Okay, so in case of a dialogue on an Android phone, right? In case your activity is visible but not in focus, i.e. not running, it's paused. In case it's not visible at all, it's stopped. Okay, and then finally gets destroyed. So there's a mechanism that manages memory, and in terms of guarantees for memory, whatever is running has all the memory that it ever needs. Okay, unless it stops responding for like I think 3 seconds, and then it says, you know, do you want to keep waiting or kills it? But that basically gets all the memory preference. The ones that are paused, they're also guaranteed to get memory unless there's no memory available for the running ones. And in terms of the stopped ones, basically they could be killed at any point in time. And that's why I think you had example where your activity gets restarted or something, and then everything gets wiped out. So there are hooks that allow you to preserve certain objects or save certain states before you get, before you go from stop to pause to stop, back to running, etc. And understanding this is very important for understanding the performance. This is where you get the responsiveness. Empirically, what I found out is that I think Android, the Dalvik VM, keeps up to top 6 apps in the memory. So unless you have something that is taking a lot of memory, and then some may get actually chopped off. One way to kind of pull up a task manager is if you keep the home button pressed for a couple of seconds. It tells you what's running here. It's kind of like a task manager on Windows. So you typically would have up to 6 things in here, and then kind of like last in, first out. No, first in, first out.
So does this mean that you can't have background tasks?
No, so these are activities. So that's a good question. So does that mean you can't have background tasks? So remember I said there are 2 important Android constructs so far that I mentioned. One is activity, the other one is intent. There are also something called services. And service is basically an activity that does not have a UI. So it's something that runs in the background. And there's some other constructs like broadcast receivers and so forth. But services are tasks that run in the background. So they don't have, they're much simpler. Their life cycle is basically started, stopped, 2 states, right? So activity is basically one of the more complicated. It's where you spend most of your energy. This is most of your app development. Everything else is actually much simpler. Okay, this is the most optimization stuff that you can do. UI is probably one of the most expensive things. For those of you who haven't seen the charts, there's an interesting chart on Dev Guide in terms of just how much it costs to do certain things. So designing for performance, and there's kind of like a chart in terms of cost. So if it costs 1 unit of time to add a variable, 5 units of time to figure out the length of a string, then to inflate an empty activity, in other words, to launch that HelloWorld with nothing in it activity, costs 3 million units of time. So that magic of like going from XML to something that you can see on the screen, super expensive. Okay, super expensive. That's why you want to kind of like understanding your life cycle. You can save certain things. What if the user gets interrupted with a phone call? You need to go back to the state. So basically your activity is going to go from running to pause to stopped. Okay, when you go back to running, it's going to call certain callback methods. So where are you going to exactly create your UI? Are you going to wipe out all your objects and recreate them from scratch, or you're going to intelligently preserve them somewhere, and you come back and you can kind of like pick up or just redraw existing objects, that kind of stuff. Yeah, question.
So you have to do the operating system
The operating system takes care of running your app through this. This is the rules of the engagement. This is how things work. you are basically provided these callbacks. Now it's up to you to implement stuff in them. Okay. So let's get into Java, and I'll kind of demonstrate this. So far we only have on create. This is your public static void main. This is your main entry point, right? So that's what we have right now. And let's take a look at our code. So what we're doing here is we're simply calling. So we're overriding on create. So notice that our activity inherits from activity. So you always do that. You inherit from the activity. And we basically simply call the super. You have to call the super for all these guys. And then the only method that really is of some substance here is this method here, where we say set content view. So we're saying for this activity, set the content view from somewhere. So let's kind of decipher what this from somewhere is. So remember I said there's a auto-generated file called R file. Okay, so this is that file. You never ever need to look at it, technically. Okay, it's automatically generated. This file is basically your glue between your app and your code and your resources. So remember how we created our button IDs? Well, here they are: button minus, button OK, button plus, text score, text scorecard, etc. Here's our layout. Here are our strings. Here's our title. So basically, our class links the world of Java to the world of XML. Okay, not just XML resources. Could be images, could be music, could be icons, things of that nature. As a matter of fact, here's our icon here that we said it's right here. It says our icon.png. Okay. So notice this. So I actually created a little, I have a little golf ball PNG. So if I take that golf ball PNG and drop it into my resource drawable, boom. Not only that, but notice how my R file automatically got updated. Isn't that cool? And now if I wanted to change what my app looks like on the screen, I'm basically just going to change in my manifest to use icon. And I could use this approach. So I could type it, or I'll just type it here. Golf. And did I mistype it? Oh yeah. See how Eclipse tool kind of tells you? So boom. So now when I launch this, it should. There's an error, which I now don't know where it is. And so this would now look like that golf ball. So if I look at the there's my golf ball, right? Golf score, and I started it. I don't know if you guys know, but you can kind of like drag this to the home screen, so you don't have to open the drawer. So there's my app. Woohoo. I can put it on the store and charge like 7 cents for it. Yeah. So that's basically the resources. So resources file is automatic. You don't care about it for the most part. If you use Eclipse, it just happens, right? But it's important that's where stuff is, because now we're looking at the Java stuff, and basically I'm setting the content of this app to be my R layout main. What this does is, this is actually doing a lot. This simple call is taking the XML file, parsing the XML file. Remember, XML parsing is expensive. For each XML element, it actually creates a new object, a Java object of that type. So when I say new, if I have a button, it's going to say new button. It's going to set all its properties as if I did button.set, etc., right? And then it basically all lines it up, adds it properly, and that becomes my view. So once we're done with this point, I now have all my UI in the Java memory, right? I do. It's all here. So now I can do interesting stuff with it. Okay. Well, so we're gonna want to do some interesting stuff. We want to capture certain events like plus, minus, OK. Those are buttons that are clickable, should do something. So to be able to capture something on that, we need to first get a hang of all our UI elements that we care about. So to do that, I'm actually going to define a global to the class. So I'll have button here, and I'm going to define minus button. And by the way, control capital O to do the organize imports. Minus button, plus button, OK button, OK, and then I have text view, score, text score, and text score card. OK, organize imports. And I think that's all that I had in terms of UI that I cared about. Obviously, I did use linear layouts and such, but I don't care about them in Java. So now that I define them, I need to get them, get a reference to them. So the way you do that is basically you say minus, let's start with the OK. OK button is gonna be find view by ID. So this is an important one, find view by ID. This is how you go into that DOM tree, whatever you want to think of it, your UI tree, and you find that specific nameless view, i.e. component, and reference it in your Java since you care about it. And this is where you refer to it by its resource ID. So r dot, and Eclipse helps you with this a lot, it's smart. So it says r dot, so I can say ID dot, and it says this is what's available. So my button OK is my button OK. So this is where I should have been consistent. So button OK with the button OK, button plus with the button plus. You get a picture. I can imagine at some point there's going to be certain frameworks that make this life simpler. So you can rely on convention as opposed to having to do all this. But for now, we have to actually do it all. So there's my button, button OK. And of course I have to cast it, so I need to add my button here. Boom. So this is now what I have to do for every single UI element I care about. So basically, let me do button. So button minus button find view by ID. So unfortunately at this point it's a little bit of typing. So button minus, boom, button plus. That's why we have a very simple UI, so we can go through this fairly quickly. Find view by ID, r.id.button plus. And then we also had our other elements, right? We had text score, which was text view, right? Find view by ID, r.id.text. And this is why it helps being consistent with naming. Card. Oops, find view by the way, I forgot to tell you guys an important thing, and that's that if you are not into typing, all my code is actually shared via the web. So you can actually go, let me make the digression, you can go to 192.168.1.180, and my entire Eclipse workspace should be available if you're on Maracana network, which is open. So you can just access it. And I have zillion and one little thingy in there, but the ones that you care about, the app that we're working on is Golf Score. Refresh it. Yeah.
Golf Caddy or Golf Score?
Golf Score. Golf Caddy is the one that's finished and working, slightly different possibly. But Golf Score is the one. I don't know why there's a little bomb icon next to it, but anyway, it's a weird icon. It's not going to explode on you. So you care about SRC. That's the one. SRC and resources layout. So far the only files that I really did much work in is /resources/layout/main XML. In other words, main layout, right? And also golf score.java, which is in SRC. Yeah. So back to what I'm doing. So I'm basically now getting the reference to everything that got magically inflated here in set content view. Okay. So now I have all these things. I can now do something intelligent programmatically with them. Well, one thing that I'm going to want to do is I'm going to want to, for example, initialize the text score. So initialize text views. Text score to 0. So I can do set text, okay, and I'm gonna initialize it to 0, okay. Okay. Or actually, you know what? I'm gonna have to keep an integer value for score, right? So I might as well just set it to score. And thank God for auto boxing, right? So basically, I'm just initializing. I'm keeping an integer value for score, and I'm just setting the text score to a certain value, and I'm gonna set the text score card set text to blank. Okay. I could have done this from XML as opposed to having that long, meaningless piece of text, but just kind of to show you something simple. Okay, so now at this point, if we ran our app, it would basically look the same, except these values should be initialized programmatically. So I always put this like this because the stuff on the side is keyboard is not really important. So, oops, something died. This is quite common. You're gonna make mistakes. Things are gonna die. So, what do you do about that? How do you figure out what's going on in terms of exception handling and all that? So, let me make a little digression on that because it's important for you to know how to do that. How do you debug, right? How do you track? How do you fix your known, exceptions and things like that? So. The simplest way is to switch over to DDMS, which is basically, and you have multiple views there, and one of the views you care about is the log cat. Okay, so log cat basically shows you what's going on, and I have an exception that says, runtime exception unable to start activity, and I'm looking for on create line 27. That's probably what I had something wrong. So line 27 is this, huh? So okay, so score to string. That's not gonna work.
Before that.
In
String object.
String active value of score. I was relying too much on auto boxing. I could have made score an integer, right? I think. So if I run it now, and again, the app just gets what's happening behind the scenes. Everything's compiled. I'll just kind of show you just for your own amusement. But so if I go to my Eclipse workspace and then golf score, right? There's one directory you don't see from Eclipse, and that's the bin directory. So if I go into that bin directory, there's basically two subdirectories, ls-ltr. So there's two subdirectories that you care about. So one is the com directory. Sorry, only one subdirectory. conf directory, that's where your compiled Java code is. And then all your resources, so all XML, icons and all that, are basically in this file, resources ap underscore. Your Java code gets compiled into Dalek DEX code. Right? That's what actually runs on the device. So that is your class's DEX file. So basically, this is not important. This is just an intermediary step. Classes.dex file is what gets run on the device. Okay, so classes.dex plus resources are packaged together. So your compile code and your resources get packaged together into your APK. And this is what actually gets installed on the device. So when I'm restarting this stuff, basically Eclipse is just wiping out automatically the APK that currently exists on the device and putting the new one in relaunching it. So I don't have to relaunch the device. Just FYI. So there's my, oops, now it works, right? So here, initialize to 0 and nothing. Yeah, question?
Sorry, I'm new to Eclipse, so could you show me the UDMS, how you saw that view?
Sure. You don't even have to do, DDMS is just another perspective. And if it's not available here, let's suppose it's killed, you can go into Windows, open View, and there should be logcat. Now, everything you can do from Eclipse, you can do from a command line. And on a command line, most of these things we do via ADB tool, which is Android data bridge to the device. So if I do ADB logcat, I'm actually now connecting to the device and piping all the logs here. So I sometimes find it easier to just tab between my Eclipse and this versus switch the perspective on the Eclipse. So it's up to you. How much? What? For these purposes, there's no difference between a physical device and a virtual device. The only time that you really care about physical device is when you start playing with sensors, things that are naturally hard to simulate on a computer. You know, like for example, I can't shake my computer to check, you know, if it's shaking and so forth. So for sensors, for GPS, if you have behind a firewall, the plugin, the emulator just does not work. It's broken. So minor things like that. But for everything else, it's perfect emulation of what's going on. Yeah. One more thing that I'm going to show you guys in terms of debugging, because it's important, because you're going to have to fix bugs, right? Is the logging capability. So obviously there's a full-on debugger if you're into that. Like if you're into Java debugging with a debugger, there's a built-in debugger, just like any debugger you would expect. I personally like log files a lot, so there's a feature there that's very useful, and that's basically something called log. So for example, if I wanted to say that I'm starting here, so I can say log dot, and then you can say this, you have multiple methods. There's D, E, and so forth corresponding to severity. So I would typically do log.d, and then I would say there's a thing called a tag. And a tag could be anything. I typically use the name of the activity or the name of the class. If it could be a service, could be activity, could be whatever the context that I'm in is. So golf score, and then you say some kind of message, you know, maybe on create started. Something like that. Okay. Now I'm gonna run organize imports, and it's not the Apache one, but it's the Android one. Cool. So that's all fine. Now you're gonna have to repeat this. If you do it the way I do it per class, this becomes redundant. So I usually put this as a constant. So I put tag here or something, and then I define my private static final string tag. Oops. Something like this. So now I have a pretty nice tagging capability, and I can say,
This is not walk for J.
I'm sorry?
This is not walk for J.
No, it's not. Yeah, and let me show you now what happens with this. So obviously, if I run my code, now it's going to get restarted. Basically, recompiled, repackaged into APK. Old APK app gets stopped, tossed out, new APK gets loaded, gets restarted. That's what's going on while I'm talking on the phone. But let's take a look at my log file. So here it is, on create started and on create done. Notice that there are two things here. The first thing is basically the severity. So this is D for debug, I for info, and then there's the tag. Okay, so if you're looking at this and you're looking through DDMS, it could be that you're looking at too much information going on here. So it gets, because there's a zillion and one, this is your system logs, so lots of processes happening at the same time. So you can do some neat stuff like create a filter. So you can filter, you give it a name, so score, golf score filter, and then you can tag by, you can filter by log, so or PID or process ID or severity. Typically, I filter based on my tag because that's something that's arbitrary, right? Score, boom. So now I have a much nicer and easier way to look at what's going on inside my app. So this is how I typically do it. More signal to noise, right? So that was the digression into debugging because it's an important one and you're going to be dealing with this a lot. Okay, back to code. So we got reference to our elements, we got all this. Now the next thing is to basically implement event handling. So event handling in Android works the same way it works in Swing and so forth. Is basically you attach a listener. So so let me do that. So basically what I'm gonna do is I'm gonna define button listeners, or I'm just gonna attach them basically. And so I'm gonna say button OK dot set. It's not add, it's actually set on click listener, boom. And you specify what the listener for this button is. You can do it multiple ways. You guys can do your inner classes and so forth. Sometimes when I train people, I find that they get lost with inner classes, especially anonymous inner classes. So to avoid explaining what the heck that is, I'm going to just say implements on click listener. And obviously there's a bunch of problems. You organize your imports, implements, you organize your keywords, you organize your imports, boom. Now it says no, you're not implementing. You say fix that error, add unimplemented methods, boom. So now there's my on-click thing, which this is actually incorrect, right? Because it's not overriding, it's implementing. Right? So anyway. So now you can add handling for your buttons. I'm just gonna finish this. I'm gonna say button plus dot set on click listener this, and button minus set on click listener this. So now I have all these buttons basically publishing their events to this being their listener. So this works just the way it works in regular Java. So I'll rename this into source, and then I can do certain interesting things such as switch on source.getID, right? And now I can do r.id.button, okay? Do something, right? Break r.id.button minus, do something, break, and then I can say r.id.button minus plus, do something, and break. Yeah. So there we go, right? So get ID. There we go. Boom. Where's the spell checker in all this? And case.
That change one step.
What?
The interface for on-click.
No. Why? It's on click listener is. And make sure there are two possible choices for that. So make sure you pick it's the views on click listener because there's I think multiple.
Okay, not dialogue interface.
All right, so now I have a structure for this, and I can say such and such button got clicked. So now I can do certain logic. Here obviously I can do. I can say score plus minus minus. You can do score plus plus. Right? So because I had the current score that's happening, right? And if it's an OK button, I'm gonna probably reset score to 0, and so that's basically I have the logic for that. Now I just need to update my text view, which is basically the same thing that we had here, right? Set score, text score, set text, and then something. So if I do that, at this point, my counting should work. Plus minus. Oh, yeah. Thank you. So it goes there. And obviously, I could have optimized this, but I'm not going to worry about that for now. Yeah. Yeah, well, maybe, as a matter of fact, this doesn't need to be part of switch, right? Because it's going to be hopefully, well, never mind about that. Yeah, I'm going to leave it like this for now. So let me actually test that this is working at this point, and obviously it's not complete, but it should be at least changing this number here. So we're waiting for that to get reinstalled. Now, basically, if I do plus, that's doing something there. And then, ideally, this is not reset. I forgot to do the set text. Oops, set text on this one. But what I need to do in case of the OK is presumably I'm gonna add that score and save it somewhere. Okay, so the way we're gonna do that is we're gonna basically set text score card append, and I'm gonna append some kind of text. You played, and then I can do score. That's fine. And then just do it quick and dirty. I'll do something like this, \n, and so we now have something that actually works. It's calling complete. Let's test it.
You might want to move that line up a little bit compared to setting it to 0.
Yeah, you're right. Good point. So it happens when you talk and program at the same time. Oops. So first we're going to do that, and then we're going to reset it. It's a better logic, right? So this should be coming back up shortly. Okay, so I played, I didn't play very well on this one. Plus, okay, played 6. This was a par. Obviously, I don't have a way to save what the par on the hole was, so I don't really know if I played above or not or scratch, right? But we have basically a very simple scorecard. We can, sure. Presumably, it should limit it to 12, and this should be a pull down or something like that, a little more, as opposed to plus minus. I could have done a pull down. That's another way to do it, but for now, what I'm gonna do is I'm just gonna simply make this look a little nicer. So this text area, I can now make which one is the properties. I can put the text size a little bigger, 20 SP maybe, and that's about it. So I think I can probably get 9 cents in that download now or something.
Is there a way to, when you go to double digits, avoid having the UI components move? There's reserved space for 2 digits, even though you're not using 2 digits.
Yeah, you could. I mean, what I could do, sure. What we can do is, so yeah, this looks pretty good. So what we can do is we can experiment here with the UI. So this is where you spend a lot of time doing this kind of stuff. But for example, let me change the view slightly. So one of the properties that I could have said is in width, there's a min width, I think, minimum width that you can specify. So I'm not sure if that works, but I'm not sure why there are 2 minimum widths. But you could specify something like, if I know that this is 24 SP, maybe I put 50 SP for width, right? So that's going to be my minimum width there, right? So you can do things like that. So here I'm kind of hard coding, but not really, because it's intelligent enough. It's referenced off of the width. So as the font scales for a user, it's going to scale properly as well.
Is there any way to reference? You've set this point size for the thing in another place. Is there any way in the properties to say whatever this is times 2? In other words, do a little math.
Not really, not in the XML, because it's not going to calculate it. It needs to be a scalar for the attribute in that. But that's where you could do it programmatically, and it's not that hard, because you can just do it from here by saying that was the text score, right? Mm-hmm. So I can say text score. And as you can see, you have all the things that you have available to you from the properties. So somewhere in here, there'll be like there's a set and get minimum, so set minimum width, which I would expect to be somewhere here. Minimum width, there you go. And it's an integer. So we would just need to now figure out what this integer really corresponds to. Is it an SP, DP? I don't really know. So that's why you kind of like gotta look at the documentation, which is you do it like this, and it says that the min is to be tried to be. The documentation is, everything's documented because it's all Java doc, but it's not very descriptive. There's not a lot of English in there, so just FYI. So so I don't really know what min width integer in this case corresponds to. We can try to put 50 and see what that means, and I can actually, sometimes you just have to learn it, figure it out this way. One thing I wanted to point out, speaking of integers, sometimes an integer, you think it's a number, but it's actually a reference to a resource, because r dot something, right? So that's a common mistake, and it's also one that's hard to find, right? Because Android uses integer references a lot, and that's to make the system run faster, as opposed to object references. But that means that you lose the compiler's ability to check the type. So you'll be referencing strings with an integer, and sometimes that integer to you intuitively may mean one thing, but it's actually a resource, and vice versa. And again, it's a runtime error, and sometimes it's harder to find. So just keep that in mind. I was gonna remove the min from here and just see what happens for that SP, right? But you'll find out when you run it. So. But the point is, you can programmatically change things like that as well. So and that should be fine. So there, it looks like it actually did it. I actually still don't know what 50 corresponds to, but
You did it in two places.
I removed it from the XML. So now it's just programmatic, yeah. So it could be DP, it could be SP. You know, I would have to do extra work to figure out. So I'm not really concerned about that.
Mm-hmm.
So we now have something that's whole and complete. You know, it can record things and so forth. We can now take this in many different directions, right? So obviously there's some logic that doesn't make sense, like you can't play negative and so forth. You shouldn't be able to play over 12. That's easy stuff. You guys can figure it out. We have only so much time, so what I was going to show you is maybe how I would go around doing certain things on the app that's already done, as opposed to coding it from scratch, just because we're not going to get too far. But now you kind of got to think of gist of how all this works. So the natural next step for this app would be to save this data, right? Because right now, not only will I lose data, let's see what happens if I go Control-Shift-F11. Not only does it lose all the data when I restart the app, but it loses all the data even when I just change the orientation, because it runs on create all over again, right? So you would want to save things in your app. There are different ways to save things on Android on the phone. They're basically, you can save it on a file system, okay? You can save it in something called preferences, and you can save it to a database, okay? So I'm going to show you, so the file system is very simple. It's basically Java, IO, plus there's a couple of helper functions in terms of what's available to you to easily list files, save files, etc. It's not the most useful thing that you're going to do. It's not the most interesting thing. You know, it's standard stuff. But before we delve into that, I just kind of want to point out that via DDMS, you can actually look at the content of your file system, select your emulator, and it's going to you have the Explorer here, okay? And basically, this is your file system. So it's got essentially three main mount points. Your data is where all your app data goes, including the apps. So all your apps are here. So here's my Golf app and Golf Caddy. Remember the APK? This is what we actually created and pushed through via the APK tool. All the app data is in your /data/data directory. Okay, it goes in here, and it's basically a sandbox off of your Java package. So for each Java package, you're going to have a file system, and that file system has the read-only permissions just for that package, right? So actually, when an app runs, it has its own Unix ID, its own virtual machine, its own entire sandbox, its own file system, and its own user ID is actually created. So there's a bunch of app_user IDs. Everything that you can see through DDMS, you can actually see through a command line. So I'm going to show you that really quickly. So if I do ADB, remember the tool, you can use the ADB shell to jump into the device. So now I'm inside of the device. Like if I do ls, I'm listing the file system of my device. If I do top, I'm actually running the top command on my device. So you can see what's running on my device. So there's the alarm clock. This is the home screen. Oh, sorry?
So you can jump up to the root and see how it's file system.
Yep. I can nuke it. Oh, here's my com.golf. Keeps running away. Com.golf. And notice it's user ID, app_19. So it's one of those IDs that Dalvik assigned to my app. And if I now, let me Control-C from this, if I now cd into /data/data where I say all the files are, and here's my com.golf, and I did ls-ltr on com.golf, Yeah, okay. You can see that it currently has group and user belonging to app 19. So obviously when it gets stopped and destroyed and restarted some future time, it's going to have a different user ID. Just a little FYI how it's organized from security standpoint. So that's one of the main mounting points. The other mount points, as I said, are the SD card, which is your free-for-all disk space. That's where you put your media, your images, things like that. It's kind of like your /TMP, just dump stuff in. And then /system, which you technically can't touch. This is what comes with the phone. The pre-built apps that ship with the phone are there, so the special APKs are here. You don't really have a good way of removing them, and so on. So that's about the file system. I guess the only takeaway is that you can only write in the either SD card or your /data/your app folder, right? So in terms of services running on the device, I mean, there's a bunch of system services, yes, that are running on the device. I don't know which ones would be more interesting than the others, but yeah, they're not like, they're system services such as like, a lot of managers, like notification manager, life cycle manager, sensor manager, yada, yada, yada. So all these like ecosystem things that manage, like I have another picture that we kind of did in a basic Android, but if you take a look at the stack, see, this is the stuff that's in your ecosystem, right? That's important. So activity manager, window manager, content providers, yada, yada, yada. So there are corresponding system services that run to represent these. So, yeah. Well, some of them may be, I don't know how the telephony works. Yeah, but nothing that we really care about. It's all underlying stuff. As a developer, you don't really care because you access it via the appropriate high-level manager. Okay, so back to persistence. So file system is one way you're going to store data, but it's not the most interesting stuff. More interesting way of storing data is preferences and database. So we have about 15 minutes. So I'm just going to walk you through what that looks like in another app, which is the Golf Caddy, which is already done. So if you want to store something in a Golf Caddy preference, so it's kind of like a similar project. I just kind of blew it up a little bit in terms of more features and so forth. But there's basically something called Preference Manager, and you can ask it for the default share preference. This would be the preference that belongs to your specific application. So you can have multiple activities, but they would share your default share preference for that application. Makes sense. One application, one set of preferences. You can then reference stuff from these preferences, in a very simple manner. Let me see if I do anything with these preferences. Do I use preferences anywhere? Prefs. Let's see. I don't use it anywhere, but it's basically name value pairs, set and get. What's interesting about this is you can get a UI for free that manages these preferences, so that you don't need to build your UI, which is the big time saver. So let me show you that. Oops. I have, for this one, I use an UI called Preference. I created this UI. And again, anything that's visual, that has a screen, is typically an activity. So this is no difference. It's an activity, but yet it's a preference activity. So it's a special kind of activity that knows about preferences. So it's a screen that's visual, but it knows how to deal with preferences. Let me just run this so you can kind of see what that looks like on the device. So this is that other app that I had. So it's getting installed and all that. So here's my one app. Okay, this one has persistence. It's actually saving in the databases and everything. When I click on preferences, it's going to launch a second activity. Remember one of the two main constructs, intent? So that's how it does it. So when I click here, the way it launches the secondary activity is via an intent. It's very simple stuff. Basically, same way I handle events. So on click, right? Here's my plus button, blah, blah, blah. I listen to the click on that preference button. And when I hear it, I basically say launch an intent from here to this specific activity. And so I create an intent and then I start activity for that intent. That's one of the main ways to use intent. There's another way where you send it kind of more general intent. I would like to open up a web page. And then the system figures out what's the best application. Is it a browser? Is it Opera? Is it Firefox? Whatever is available on the phone. Right? So that's a different type of intent. But basically, you use an intent to say, I want to get something done outside of my own realm of my own activity. So this launches this new activity preferences. And preferences, as I said, it's super simple, one-liner, add preferences from resources. So there's basically an XML file that defines these preferences. And that XML file lives in resources XML. And it's basically just an XML file that looks like, you can have different it's got different structure like this. You can add, it's got name value pairs, but you can add, different pull downs, things of that nature to it. And this will actually, yeah, you had a question?
So that could be something that you hide from the user and where you store information, right?
Yeah. And just if you guys are curious behind the scenes, what's happening is if I go into that, if I go to /data/com.golfcaddy with a double D. Okay, so I'm now in that directory. So I have, remember that sandbox that belongs to this app and it's not visible to anyone else. It manages it very simply. There's basically, you know what? Yeah, I need to leave this. Now let's do ls. Let me see. I don't have anything set. So let me actually set something. Oops. Okay. Password secret. Okay. Go back. Okay. Now there is a new file, right? It says here shared preferences. So it actually only creates it, lazily when it needs it. So there's a file called directory called shared preferences. So if I cd shared, there's a new XML file called golf caddy preferences XML. You can just cat it to XML so you can see that that's how it stores stuff. So that whole entire UI plus mechanism for retrieving and saving plus everything is done automatically via using preferences. Okay? Yeah.
But wouldn't you want to have an initialized, set of sort of blank preferences in there that goes in any previous kind of data?
Yes. Would you? Yeah, you would want to set default preferences. In this case, I didn't have any. You would do that from. Remember, preferences initializes itself from XML preferences file, which was this XML file, which is part of your resources, which you can set in here. You have, different things you can set. From layout to enable, disable, to default values, to order, to, boom. So you can even load the references from another resource file, etc. But good point, yeah. And so that's preferences. You use it for preference type of things, right? Now for golf application, we would normally want to save it into a database. And since this is a day on its own, like just to explain how databases work, I'll just give you a really quick overview of all that because I think it's still going to be a good takeaway for you guys. Basically, Android ships with SQLite. Did you guys know that? I knew that, yeah. So it comes with SQLite database. SQLite database is super simple, zero administration. It's serverless. There's no server. There's nothing to connect to. It's basically a simple file. You connect to the file. It's all in there. As a matter of fact, the file is, like everything else, if we're poking around the file system, it's, remember, there's a databases directory. If your system has database, cd databases, and there's going to be a file called scores. And my SQLite is a very simple SQLite 3, name of the file, scores db, and you can do .schema to see what kind of schema was used to create it. You can do select, select star from from scores. And it shows you everything that's in that particular table. This is exactly the same on your desktop, on the phone, on Unix, Linux, doesn't matter. It's a SQLite database. It has nothing to do, it's nothing Android specific at all. So now let's look at what is Android specific. So what is Android specific is if you are gonna use a database, there's something that's important, and that's a database helper. So you need something called a database helper. So a database helper is basically you create it by extending SQLite Open Helper. Okay, and there are a couple of things that are important in there. You got to define your constructor, and the constructor is going to have the name of the database. So that's going to be that file scores.db. And other than that, the other thing that's important is a version. So let me talk about this really quickly. What happens is you're gonna put your app on the market. People are gonna download. You're gonna have 1 million people using your app. Now you change your schema, and now there's an upgrade for your app available, right? Some people have your app, some people don't have your app. How are you gonna migrate the schema? How are you gonna deal with 1 million people who already have your app and a ton of data in their phone versus the people who never had your app before? How are you going to deal with people who are two upgrades behind, and so forth and so forth? So the mechanism for that is basically the DB version. And essentially, if the database, if it's a version installation, so user downloaded your app first time, never had your app before, what's going to happen is this method is going to get called onCreate. And onCreate is very simple. You just specify some kind of SQL, so create table, yada, 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 and you execute that SQL. Okay? So this method gets called once and only once, ever, for a particular user. From there on, as the user upgrades your applications, they call onUpgrade. And this is where you would typically provide your alter table statements. So, and your logic. If you're database schema version 7 and they're at version 4, you gotta somehow bring them up to speed, their schema. And hopefully not, the easiest way is just blow up their data and, create table. Drop tables, create table, right? That's the easiest. But you don't want to do that, right? Because you charge them, what, 9 cents right now? So yeah, they'd be pissed. Yeah. So yeah, that's why they ask for money back. So yeah, you want to do the alter table properly. But once you have this helper, and this helper is very simple. Again, you just have onCreate and onUpgrade, and basically you're just executing some kind of SQL. Once you have that, in your code, your database stuff becomes fairly simple. You have statements like insert, update, and delete. So db insert, db update, db delete. And so this is one of the more complicated ones. I have to put some kind of data, and basically as opposed to executing a SQL statement and creating my spaghetti SQL code, you don't want to do that. You'd rather do a prepared statement, equivalent of prepared statement. So you say insert table name, and then you basically provide all the values. And the values are packaged in this name value pair structure called content values. Nothing special about it. You just say key value pairs. Okay. So those are some constructs. Once you write it, it becomes really a pattern. There's really nothing too complicated about it, right? It's just db insert, update, and delete, and query. Let me see query if I have it. I probably run it in my own create. db query, and as opposed to running a SQL statement, I say table name, and then these are equivalent of star, having, grouping, or this is ordered by all the parts that you can put in a SQL statement. So essentially, this is your prepared select SQL statement. Okay, I'm basically running select star from certain tables. So that's why I have null, 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 null. But here, if you put here, here. So it's table name columns, selection args is, something equals something. It's the where name value pairs, right? So selection args. And then you have grouping, having, and ordered by. So this is kind of like just a very, very quick overview of how the database stuff would work. So that's kind of like the main stuff to build, an app. So you have the UI, which tends to take most of your energy, and then you would create a way to store all that stuff in the database, typically, in most cases, right? Preferences you can do in preferences, such as like, preference type stuff. File system is not something you typically use a lot of unless you guys are doing something special, but I'm kind of referring to your generic Android mobile apps. So just kind of wanted to kind of show you all that stuff. Networking, most of that other stuff is just your plain Java networking, so there's nothing really special about that. There's some other constructs that we didn't, cover: broadcast receiver services, sensors, things of that nature, which, beyond what we can do in 2 hours is normally a 5-day conversation. But is this kind of making sense? Is everyone kind of following? Yeah. Okay. Anybody has any questions, comments? I'm trying to keep it within the time frame. So,
is the Java sound available on Android, or is it this special sound thing?
You don't have a sound. There's basically, for multimedia, it's very simple. There's media player and media recorder. And media player is intelligent about pretty much all the main codecs. So you just say media player. I have all these little examples. I have, audio demo that shows exactly how to do that. So you just basically drop your music either as a resource or you can stream it or whatever. And you just say, play this, and it's automatic. Similar for video and for web. So for example, if I want to embed a web page, not like pop up a new browser, but embed a web page within my activity. There's something called web view. Same as text view or button. It's just a widget. You drop it and you set it a source, right? Video, same thing. You can just drop a video, and I think, did we use here for about, was this a video? Oh no, this was just another activity. So anyway, you can just easily drop video, and that it's a no-brainer, all that stuff. So if you have this headset from T-Mobile, so if you have an app that you download, so it's not available via the market, right? You'd basically use ADB. Everything that you want to do, hold on. Everything that you want to do here, use ADB tool, and there's ADB install, and then you say, hold on, let me see. I actually have Eclipse. Let me see, ls star ADB APK. So that's the package. So I have something called File Manager that I downloaded from Open Intents, which is a good site. So I can do ADB install File Manager APK. And this is basically pushing the app to the phone, so transferring the actual APK, installing it, registering, doing everything that it needs to do. This is what happens in Eclipse automatically when you click Run on the phone. One thing that I also didn't show you, which is also relevant in terms of moving data between your phone and your computer, because you need to do that back and forth. So there's ADB push and pull. So for example, if I wanted to put some file onto my SDK card, let me see, I have this sample video. So I can do ADB push sample video, and I can do /SD card. So now I'm pushing this video onto my phone, and I can validate that by going .quit. So this is your equivalent of FTP push and pull. So if I go into /SD card, there's my video there, and you can also verify, by going into your favorite DDMS, and there's my video there. And if you are more of a graph, kind of ID kind of guy, so there's push and pull available here. So you can pull this from a device and it brings up save as, and this is a push into the device. Another cool feature is, in terms of this, is if you want to take a snapshot of what's going on your device, bang, and it brings you a snapshot of what's going on in the device. I thought that was kind of cool.
But that's your virtual device, not a real device.
It doesn't matter, same thing. So if I connect my phone, as I said, for the most part, these things are identical. One thing you just have to remember on your physical phone is to go into settings and enable. There's a well, I don't. Oh, mine is enabled. It shows up right here. There you go. You want to see what's on my phone right now? That's what's on my phone right now. Okay. You want me to poke around my phone? Let me shut down this, because otherwise I can just. So now if I do ADB shell, guess where I'm at? I'm inside of my phone. Here the process is running on my phone. And this is my live phone. You know, so I see I have Wi-Fi going on. I have, this is different, right? So different sets of apps, different everything. So if I want to deploy what we just wrote on my phone, so I'm just going to deploy this app on my phone. I never had it deployed. So it's doing the same stuff.
What's the setting?
Oh, it's under, I'll show you. It's under settings, application, development, USB debugging. So here's my little app, and I can, you know, I played 4, and it says it played 4, and I can actually verify here. I can show you like this. Boom, see, works. So if you go, if I go into settings, so I can show you like this. Settings, then applications, refresh. Then development, refresh, and then USB debugging is what you need to enable.